Assalamualaikum. My name is Mohd Haiqal with Mohd Jazam 2180079, and my supervisor is Dr. Muhammad Nazrin bin Daud. I will be presenting about characterization of granite residual soil using X-ray diffraction method. For introduction, residual soil is the product of rock weathering on top of fell rock that is still present at the place of origin, and it covers more than 3/4 of the land area of the Malaysian peninsula. Granite and sedimentary soil cover most of Malaysia's land, except in coastal areas where soft clays predominate. Granite is affected by long-term geological movement and climate change in certain geographic movements. Problem statement. Granite residual soil, their condition features and qualities are crucial in assessing the viability of their usage in construction, so as well as their behavior and effect on the surrounding areas. Granite residual soils have been linked to many construction materials, and in some circumstances the failure of soil slopes as a result of strength loss owing to water seepage. Soil study is required to collect and record such data for present or prospective use in planning in areas where it is abundant. As a result, the study is an attempt to evaluate the nature of the granite soil in selected location and its many characteristics in relation to the specific engineering properties it possesses. And the objective of this project is to determine the physical properties of granite residual soil by performing laboratory experiments to analyze granite residual soil using X-ray diffraction method and comparing X-ray diffraction from two different locations of the same soil type. Methodology. So I will be going through one by one. So soil sample collection and soil sample preparation, basic properties of soil, X-ray diffraction, and analyze soil sample. So the soil sample was taken from two locations, which is shoveled the soil at 1 meter depth. The soil sample was placed in a container and wrapped in a plastic to prevent from moisture evaporate. The X-ray diffraction machine, I've used the X-ray diffraction machine at University Kebangsaan Malaysia because the availability in this education institute is cheaper. I will be using diffract.eva for software for raw data analysis. For basic properties of soil, I've conducted the Atterberg limit and sieve analysis. So the results, the natural moisture content of granite residual soil is 27.7, the specific gravity is 2.56, the particle size distribution, which is clay 19%, silt 24%, sand 38%, and gravel 19%. For Atterberg limits, the plastic limit is 39.5%, liquid limit is 25.3%, and plasticity index is 14.2%. So the two graph below is the XRD graph that I've obtained. So it shows a different peak intensity from both of the graph. So they were different in peak intensity from both of XRD graph. It is due to the fact that there is more periodicity than of other directions. The height of the peak will be high if there is a preferred crystal orientation. The peak will be low if the atoms are arranged in a chaotic or a random order. The higher the electron density variation, the higher the intensity for the plane reflected in the XRD pattern. Peak intensity represents the atomic positions in the crystal structure. And lastly, so there are many ways to determine the physical properties of soil sample. Sieve analysis and Atterberg limit tests are an easy test that can be conducted through thorough preparations with accurate results. X-ray diffraction method is a process that can analyze any sample to determine the sample's crystallinity, whether it is amorphous or crystal shaped. In some universities, availability of this type of machining is not accessible to the students. The students have to run the machine at other universities. So my recommendation is that this machine serves many purposes in analyzing soil sample. It will be more convenient if there is one in this education institute. That's all from my presentation. Thank you.